Alright, guys. So let's begin with another topic in object-oriented programming and Python programming. So here today we are going to discuss about inheritance. So we all are aware what basic inheritance is. So and we are also eventually aware about the fundamental concepts of object-oriented programming. So the major core principles we are aware: encapsulation, data abstraction, inheritance, and polymorphism. Right. So what happens basically in inheritances? Can anybody answer my question? So inheritance is basically inheriting the properties from some parent, grandparent, or great grandparent. Right. So by acquiring those properties, even we can create our own new properties out of it. Right. So this is what the basic concept of inheritance is. So inheritance is a very powerful feature when we talk about object-oriented programming. So it refers to defining a new class with little or no modification to an existing class. The child class or the subordinate class is being derived from the base class, or it will be called as better as parent class. So the derived class inherits the features from the base class. We can further add new features to it. So how this concept is usable to us, because it helps in reusability of the code. That is, once the code which you have written, you are not required to rewrite it, but you can use the same old code and it can be used. With the help of that reusable concept, you can create a new code out of it and you can have existing code. Now, how the taxonomies are being defined when we talk about object-oriented programming is concept inheritance. Right. So let us suppose we are having a base class or a parent known as vehicle. Vehicle is what? This vehicle is basically something which is moving. Right. What is the basic definition of a vehicle? Vehicle is something which is being moving. It may have few properties that may have two tires, two brakes, to accelerate the speed. We are having accelerators in it. So this is what the basic vehicle is. Like, what these properties can derive and can be created into entirely different structures. Like from the concept of vehicle, you can create even thing like bikes. And, we are having cars. So bike is inheriting the features that it is having only two tires, whereas car is inheriting the feature which is having four tires. Now buses is something more expanded version of this sort, and truck is further. So bikes, if we talk about, we are having pedal bikes like bicycles, which no motor or nothing like this is there. But when we talk about motorbikes, it has entirely new feature that says about it is having some motor, and if motor is there, it requires some to throw the diesel in it so that it can move ahead. And again, a huge features of vehicle has been inherited into the cars. We talk about car, there are lots of varieties of cars like pickup cars, sports cars, state cars, vans, convertibles. Similar goes on. But what basic thing is being derived from the base class is that a base class is having few features. These features are perhaps used further and extended more and more in terms of bikes, cars, buses, and trucks. So this is what the child classes, bikes, cars, buses, and trucks, the child classes. Right? Now, let's see to the basic Python syntax of inheritance. Right? So when we talk about inheritance, we are having basic class name. So here the class name is there, and the name of the base class, since we talk about the base one, is base class followed by the coder. Guys, I told you earlier also that if you're not utilizing any other concept, if you're not using the class further and further some for some purpose, and we just want to define it and want to use a creator. We can write a keyword over here named as class. Okay? Now, similarly, the derived class through which we want to have the properties of base class in it. So the key syntax for writing this particular way is the name of class is the keyword. Now the class or a child which is inheriting the properties from the base class has been written here. After that, a round brace is there in which the class from which the property is being inherited, that is the parent class, name should be written here, right? It is a little bit different from C++ as well from Java, because there we wrote something known as extends or inherited or XYZ type of thing. But here, particularly, we are not creating any confusion. The very first thing, the derived child name will be there, followed by, in brackets, the base class name from which we are trying to inherit the property, followed by the colon name. Since I just want here a declaration type of thing, we do not want to extend it as of now. So I'm simply writing a fast keyword over here again, and later on, whenever we require, we can extend this particular class. Okay? So this is what the basic Python syntax for the inheritance. Now here is an example we see about. So what does this example say? This example is speaking about, all right, so we're talking about class, and now we want to see that how the class is being properly defined in the terms of inheritance. So what we have really taken here is the base class is named as defined as robot, and then we have used a constructor over here which is defining that what kind of robot it is or what is the name of our basic parent robot is. So the name has been defined here. So we have already seen the self-referencing variable or the concept that is known as self. So self.name has been used here to initialize the name of the robot. Then we are defining a method here, that is, it is saying hi to someone. So the robot name, and it is saying that hi, I am this one. So it is basically welcoming and feature to the world, right? That hi, I am the XYZ robot. Now, similarly, what we try to do, we are using another class, another inherited feature, which is using the class that is the physician robot and followed by the parent robot. So what property it is inheriting? That it is inheriting the name in it as well as the method which has been defined here, right? So again, so what we are trying to do, do not want to extend this parent child class as of now. We're simply writing pass over here. So now it is understood that this inherited or the child class is being simply using the properties of the parent class. It is not having any of its own methods or attributes in it. Right? So now let's talk about if X is the object here, instantiation of the parent class, which is saying a robot, and a robot parent robot's name is known as Marvin. Right? So if we are initiating it, then it will simply say, okay, Marvin is there. Now we are giving another object that is the y is equals to physician robot. Physician robot is named as James, right? So now guys, let's see, first of all, there are two concepts which are coming up here. The very first one says the print X. X is what? Talk about. X is a robot, right? X is a object. Then this object is of which type? So the type is written over here. Now similarly, we want to check what is the type of this y, because this y is simply inheriting the properties of base class and it is not having its own properties or any other own attribute, right? Attribute or any method in it. So we are trying to print these two values here. And finally, what we want, our y method, y object is instantiating or is calling the method say hi. So now I ask you a question. Let me know what is the answer for this question. So answer will be, according to me, hi, I am James, because whichever method is being called of the derived class, right? And derived class is being calling this method from its base class, right? So let's see arrow by arrow how the description is being there. So parent class in the green arrow here box, we are representing the base class. Now, after the base class, we are defining here the derived class. So, derived class is the physician robot, which is inheriting the properties of robot, which is having the name as well as a method, attribute name and a method. Now, this is what the derived class is. Now, let's see how the inherited method is being invoked here. Inherited method is being invoked here by the use of y object, which is calling the method from its base class, say hi. So my answer will be what? Sorry, my answer will be hi, I am James instead of Matt. So this is what my this basic program is doing. I just wish to know from all of you that what does this printx statement will do here and print y statement will do. What kind of type it is going to return here? It is going to return some integer type or something like this. Guys, kindly ignore this particular thing, right? Actually, mm, if these are only two underscores here and two underscores here, so don't get confused with this silly mistake of mine, right? Okay, so this is what a basic inheritance works, right? I hope I have cleared myself here in terms of inheritance. Now, when we talk about inheritance, we get the two basic concepts. The one is the type, and another one is instance, right? So, what basically a type is, and what basically is instances, right? So, guys, these are very basic features. You must aware of this all things. So, let's first of all just read this particular first slide by yourself by taking a pause of 2 to 5 seconds from my side and understand what the type is trying to say. Okay, so I'm again reading for you. People frequently ask where is the difference between checking the type whether checking the type function or function is instances variable. Now I'm giving you a clarification, very simple but yet very important it is. The type function returns the class type of the argument object passed as a parameter, right? The is instance function simply returns the boolean value that is true or false. That is, it checks first of all the first argument, that whether this is object type or with the class it is accordingly behaving or not, right? So this is what is instance is returning something type boolean, right? Whereas the type function returns the class of type that is integer, string, float, double, etc., 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 right? Or whatever that is the type is. See, list is again a type, tuple is again a type, data type. So it may have something like this and that value of that type also. Okay, so don't get confused with all these things. Now let's see here what is the type versus instance. Okay, so from where we have checked out this type thing, right? First of all, I need to let you know that I asked you a question in previous slide X type, Y type. Now let us see how this thing is being behaving here. So again, I am having the object here, X, it is checking from the base class and the robot's name is Marvin. Y is from the derived class, object is from derived class, which is having the name, robot name as James. It is a physician robot. Don't get confused in these two robots, right? I hope I have made myself clear in these two concepts. Now let's talk about print statement. So I am checking here is instance x comma robot is instance y comma robot. I told you earlier also that this particular thing will yield answer in some kind of boolean value. Now let us see how this particular boolean values will reflect over here. Now another print is instance x comma physician robot. So guys, if I talk about x of this robot, I am representing this robot, right? And then I am having y of this robot. This means I am representing y of this robot, right? Now, you have to understand this thing very nicely and very clearly. If I am indicating this x of robot, it is indicating to this. If I am indicating is instance y of robot, is it true or false? I guess it is true because y is derived one and it is having all the properties of the base class robot, right? Now again, I'm having is instance of x comma physician robot. So can x be able to having all the properties of physician robot? I'm having a doubt over here. Now is instance y comma physician robot, whether it is true or not, it's your guess. Now I wish to know about type y comma type y is equals to physician robot. I wish to know the type of this particular robot, right? What kind of robot it is, and whether this type of Y, this type of objectified Y, is equal to physician robot or not, right? So here are few questions we want to check. X robot is of which category? Is instance Y comma robot, whether this Y belongs to robot or not. Okay? Then this X is a physician robot. Can the base class be able to, inherit or have an excess of the base class is having the access to the derived class properties or attributes? Yes or no? We have to see this. And another thing is the derived class is able to access its own data from the base class or not. Now, the type we are required to return here of which type it is, and then similarly we want to check whether this object of this type is able to compare its own values with the derived class of its own, right? So let's see what is the answer here. Okay, true, true. I told you that X comma robot is what it is indicating one in the same thing. That is, yes, X belongs to this robot. This X object is belonging to this robot base class. Now is instance of Y. Y is what? The derived class object. So yes, it is also having the access from its base class robot, right? So that's why answer is true and true. Now I was having another objection here, whether this X that is from the base class can have the properties of the derived class. No, it cannot have, right? So this is what the property. It is exactly like something that a child may have features of his father, but a father cannot have the new features which has been inherited in him from the other gene, right? Can have the same gene cannot be inherited by the father himself, right? So this is what it is. Now, the last one is Y is again a derived object for the derived class physician robot. Yes, this is also definitely true. Now, let's see. We have tried to understand the concept of type. It will return the type value. So, yes, it is returning that main type it is, and the class main type, and the physician robot it is talking about. Absolutely right. Now, one of the most important concept here was whether I can be able to compare the derived class with the derived class object type. Either we can do this thing or not. Yes, we can also do this kind of comparison in Python programming. This is one of the very basic and important feature when we talk about type versus instance. Is instance, right? Is instance means is it belong to this type? We have to answer true or false. If we want to know whether it is a type or not, yes, you have to answer it in a very firm type that we expect from the compiler that it should return in a very specific type. Now, we are having a few basic questions on the concept of inheritance, right? I have defined a class A, I have defined a class B, in which I am taking A as properties, deriving all the properties of A into B class. Now, what happens? I am having another class C. It is deriving the properties. It is deriving the properties of B class. Now I am having X as an object of class C. His instance X belongs to A. We want to know whether this grandchild can be or is it accessing all the inherited properties from its grandparent or not, right? Question is quite simple here. This grandchild is able to derive the properties of its great parent or not, right? So in this instance, we all know it represents answering true or false. So let's see what is the answer. Yes, true, right? Since we are having the properties of how it is possible, the first question which asked here, you can ask here, how it is possible. Since B is having all the inherited property of A, then C can also have all the inherited properties of B. So B can also directly having the properties of A, right? Is that clear? So let us suppose in this class A, we are having the surname, say some surname Sharma. So Sharma is the inherited baseline of this particular family. Then a father is writing here some name in front of him, his name ABC Kumar Sharma, right? Now, suppose there is another class in which we are taking. This is what the middle name, right? And now the last one is talks about the name, original name. So the grandchild is having name. So suppose this name is Vivek, right? So what this name or what this entire name will become, right? Vivek Kumar, Vivek Kumar Sharma, right? So the lineage of surname is inheriting from along. The middle name is being passed by the second generation and it is having its new name, that is Vivek, and it is having all the inherited properties of its base and base to the base class, right? So this is how my code is being prepared here. So you can even write the code in a simple way. Right? All right. Then inheritance is having one of the very beautiful feature that is known as overriding. Right? Overriding is object-oriented feature that allows a subclass or child class to provide a specific implementation of a method that is already provided by one of its superclass or parent classes. The implementation in the subclass override or replaces the implementation in the superclass by providing a method that is the same name, same parameter, or same and same return type as the method in the parent class. The version of a method that is executed will be determined by the object that is used to invoke. I think you all have done overriding in the Java also and in the C++ also. Python having this also this concept that is known as overriding. Let's see how this works, right? You cannot understand these things fully until or unless we are having some examples over here. Guys, please avoid this init time and again. Let me do this control V so that it is and this init is having so if by mistaken somewhere this two underscores left away, then please do consider them as this. Sometimes this happens, we cannot help it, right? So let's see here what how the method overloading is overriding is being called upon. So I'm having a class taking as robot. I'm having a child class, having a physician robot. In the robot class, I'm having the name, right? I'm having an attribute that is the name itself. Now, to access that name or to have use of that name, I'm saying hi to that name. So that's why I'm defining a method here. This method is saying hi. Now there is a class physician robot. All right. So physician robot, what is trying to say? It is simply saying hi to itself, right? All right. So physician robot is saying everything will be okay. Self.name takes care of it, right? Suppose the name of this new robot is Marvin. So Marvin is saying Marvin takes care of it. Okay. So now let's see how the concept of overriding works here. Okay. Now y is equals to physician robot and we are passing some value J. Since this object is of which type? Derived class type, right? Physician robot. So it will invoke which self, which method, say hi of this one. Now, if it is saying everything will be okay, James, take care of it. So, which method will be invoked? Through which this particular method will be invoked, and answer will be this one, right? So, it says what? It says, hi, I am, which name? James, and everything will be okay. If it has been called about, right? Right? If it isn't called about. So, this is what the overridden method here. Everything will be okay. James will take care of it. Right? So this is how the overriding is being worked here. It overrides which one? It overrides this definition, right? And using this one. So this is how the overriding is able to do the thing. Now question arises, can we be able to access the original method defined in a superclass from one of its own derived class that overrides such a method? Yes, we can. Right? If a method is overridden in a class, the original method can still be accessed. How it is be possible? For that thing, we need to apply our brain here. The original method defined in the superclass can be accessed from the derived class by calling the method by its name simply like that robot.save underscore higher y. So it will overwrite it. Okay. So now let's see an example here. Y is equals to position robot, that is dot change y dot say underscore high is my method. Now I wish to call about or I will override the concept. So what I will do is I want to print now the traditional robot way of saying hi. It's fine. Why this particular thing, right? So how it is being doing? I am suppressing the new way by using the robot base class dot say hi. Right? So initially it is invoking and then later on which method? The method of derived class by the Google. So it will say everything will be okay. Dog James take care of you. And now the traditional robot way of saying hi. Hi, I am Dog James. So this is how the original method is being called upon and the new is being called upon. Could you please just let me know that in which way it is called upon? So the first one which has been initiated earlier has been called upon first or the later one has been called upon first. I'll let the word to you guys to understand. Now another question is how I'm having for the override. Can we access the original method defining a superclass from one of its derived class that's override such a method? Yes, we can also do this thing. How can we do this thing? Simply, the way of calling it as the same, that is the robot.say of higher y. Now, I am having few questions here. There is a concept of overriding, there is a concept of overloading, and there is a concept of overriding. Overriding we just now saw. Overloading and overriding we have to see one more time. Overwriting concept, guys, is not at all related with object-oriented programming. Overwriting can be done anywhere. Let us suppose if you have defined a variable a is equals to 20, then a is having variable a is having the dominating value of 20. After some time, we have done with our work. We simply initialize the value of a is equals to 30. So what a variable will be having now? 30. That is the original value or the old value of 20 is replaced now by the 30. So this is what the overriding concept is. It has nothing to do with the concept of object-oriented programming. Since we just have to introduce you to this concept, that's why we just did it. We have already seen in the functions there is nothing known as permanent values. We keep on changing the values time and again. Right, so this is what it is. I'm giving you an example here. I told you about the function and the answer is being given. Now, the concept of overloading. Overloading concept says what? Overloading is the ability to define a function with the same name multiple times, right? Having the name of the function is same. Parameters may be different or whatever the way it is, right? So we initiate with the same name and call it at different places. Now, let's see whether this concept exists in Python or not. Right? So the second point is the definitions are different concerning the number of parameters and types of parameters. Yes, the name of function should be same, but the parameters which we are passing from this particular function may be different. Now, the third thing is its ability of one function to perform different tasks depends upon the number of parameter or the types of that particular parameters. Yes, absolutely right. We cannot overload functions like this in Python, but it is not necessary either, right? So unfortunately or luckily we have to study a little bit less. The concept of overloading is not there in Python programming. Object-oriented programming like Java or C++ implements overloading. Does that mean that Java doesn't have any concept of overloading? We have, but it is independent, right? We do not use it from the user's point of view. But yes, if the concept is there, then we can use it in its original case. Now, another question which comes here is that do we have the concept of multiple inheritance? C++ definitely have the concept of multiple inheritance. Java do have a concept of multiple inheritance, but the we call it by another name. We all need to name that. Let's focus on the Python, that whether the Python is having the concept of multiple inheritance or not. Right. So we have covered inheritance or more specific singular inheritance. We have seen the class inheritance from base class to another class. Multiple inheritance is having feature like, let us suppose there is a concept known as car, base class, and there is a concept called vehicle, that is another class. So no, that is actually wrong. Mm, we will see through an example. No, right? Multiple inheritance, on the other hand, is a feature in which a class can inherit attributes from methods from more than one parent. What I really need to say is that the derived class is accessing the feature from more than one parent. If that concept is allowed, then it will be of more and more confusion, right? So let's see how Python does this, or does the Python is having this concept in it. Or the last point which indicating here is the critics point out of the multiple inheritance comes along with a high level of complexity and ambiguity. Right. Yes. So, and situations known as the damming problem. So, this level of complexity and ambiguity defines or leads to the damming problem, right? What basically damming problem is? Damming problem is. Damming problem is. This is what the damming problem is. So, we are having one base class, and these two are inheriting the properties from this particular class. That is okay. Up to this concept, that is okay, no problem with that. But what will happen when this D is deriving the properties from the same B class and C class? Then what happens? Then it creates a problem. That is problem is known as deadly diamond of death, right? Now we will see what happens later on. But prior to that, we see an example of multiple inheritance, how it is being done here, right? So class name is robot, and there is another class known as physician, right? So class name robot is having one attribute named name, and one method that it is calling itself, hi, I am XYZ robot. Now there is a class physician. Physician is having specialization. Like what kind of physician is? Now the physician is saying I'm having specialization, specialized in bone kind of physician, or the upper body physician, or something like general physician, XYZ physician, etc. Now, the another thing is what it is trying to do. The physician robot, that is the derived class, is trying to inherit the property of one base class named robot, through which it can be able to access the name and one method. Now, the physician class is also having one method, and it is trying to say that I'm able to access this particular robot. Now we are defining a constructor of it. Robot dot init self comma name, and then position in it self comma specialization. Everything will be okay. The self name takes care of. We are trying to access which one? Self dot name is the property of the robot class. Let's see what happens here. Example of multiple inheritance output, right? Now, how the things will be invoked here. Let's see. Y is equals to physician robot. I'm trying to put the name over here as James, and cardiovascular medicine is the type of physician thing, which is the reciprocal. Now, Y calls the method C dot C underscore high. C underscore high is the method from the base class of robot. Now y dot print underscore specialization. So y of print underscore specialization. So this method is being invoked from here. So it will put some values here. The physician says everything will be okay. Since we are writing here that everything will be okay. Sorry guys, sorry, I have created a confusion here. This say dot high is of this one invoked, right? Because this is what y is, right? This is what the y is. So forget about that previous confusion. Focus on this. So it will be saying that everything will be okay. Self dot name will take care of it because method overriding is going on here. Everything will be okay. James will take care of it. Now, print underscore specific specialization says my specialization is cardiovascular medicine. It is saying something like this. So, okay, fine. That kind of thing can be done over there, but there are some complexities in doing that when we try to understand this thing. So I told you that this kind of thing leads to the deadly diamond of death, right? What basically it says. It is basically defined as a diamond problem sometimes on their own known as this name. It's generally used for the term in ambiguity because what happens here? Confusion arises. First of all, if we do not define here, there will be always confusion which have to be invoked always, right? Now, let's see what it is trying to say arises when two classes B and C inherits from the superclass A. That is entirely okay. A parent can have two child, right? Now, and the B of another class is inheriting the properties from the B and C. Now, let us see what happens. If there is a method M in that B or C, or both of them has overridden. Now let us suppose a some property of this has been overridden from here to here and another property has been overridden here to here. Now if I want to add or inherit the property of summation method, which summation it will call, it will always be an ambiguity, right guys? It will always be in confusion from which particular part of base class it is deriving the method sum, right? Or M, which has been talking about. So if overridden has been done, then what will happen? So these are the kinds of confusion with this particular case, right? So let's see here the diamond program example. M of A is the base class, B is the derived class, C is another derived class derived from A base class, and D is trying to define B and C. So at the end of the day, we will always remain in confusion then which B or which C does this class is being called up. So this is what the diamond problem is. Try to run these basic two programs and understand the concept of inheritance in very fine and refined way. I tried to create these particular slides as simple as possible because a classroom teaching is entirely different from virtual classroom teaching. So if you are having any questions, you can always ask on WhatsApp. Uh, in the meantime, if possible, I will again create some kind of hands-on on this particular inheritance as well as classes and objects and so on. So as of now, I'm calling it a day for the concepts of inheritance, and we will again see the new concept in the object-oriented programming as soon as possible. So let's call it a day, guys. Thank you so much for your kind attention. We'll meet you another time. Bye bye.